we are given the zero message, which is just a sequence of zeros. Now let's call the length of our message n. We want to show that the encoding of the zero message is just a sequence of zeros. In particular, the encoding of a message m is going to be p of 1, p of 2, all the way up to p of n plus k, where p of x is the interpolating polynomial for the message. Now what this means is that p of 1 is equal to m1, which is 0. P of 2 is equal to m2, which is also 0 in this case, all the way up to pn, which is equal to mn, which is 0 for the zero message. Now we can find the polynomial p using Lagrange interpolation. However, we can also notice that since the output of the polynomial is constant, the polynomial must be p of x equals 0. Now, plugging in p of x into our equation for the encoding gives us that the encoding of the message m is just a sequence of n plus k zeros. Suppose we are given a message m of length n. And we are also given some constant alpha. Now let m prime be alpha times the message m. So m prime is equal to alpha times m1, alpha times m2, all the way up to alpha times mn. Now, we want to show that the encoding of the message m is just alpha times the encoding of the message m prime. So the encoding of the message m is going to be p sub m of 1, p sub m of 2, all the way up to p sub m of n plus k. The encoding of m prime is equal to p sub m prime of 1, p sub m prime of 2, all the way up to p sub m prime of n plus k. Now, p sub m is the interpolating polynomial for the message m. And similarly, p sub m prime is the interpolating polynomial for m prime. Now we know from Lagrange interpolation that p sub m of x is equal to m1 times delta 1 of x plus m2 times delta 2 of x, all the way up to mn times delta n of x. And we know that p sub m prime of x is going to be m prime sub 1 of times delta 1 of x plus m prime sub 2 times delta 2 of x, all the way up to m prime sub n times delta n of x. Now, plugging in values for m1 prime, m2 prime, all the way up to mn prime, using the definition of m prime, we get alpha times m1 delta 1 of x plus alpha times m2 delta 2 of x, all the way up to alpha times mn times delta n of x. Now, factoring out the alpha leaves us with alpha times Pm of x. Now remember, we wanted to show that the encoding of m prime is equal to alpha times the encoding of m. This is showing that p sub m prime of 1 is equal to alpha times p sub m of 1. P sub m prime of 2 is equal to alpha times p sub m of 2, all the way up to p sub m prime of n plus k is equal to alpha times p of p sub n of n plus k. Now, since we have shown that the polynomial p sub m prime is equal to alpha times the polynomial p sub m, this is immediately true, and we are done. Here we are given two messages, m, which we will write as m1, m2, all the way up to mn. And we are also given the message m prime, which we will write as m prime sub 1, m prime sub 2, all the way up to m prime sub n. Now let m double prime be the message m plus m prime, which is equal to m1 plus m prime sub 1, m2 plus m prime sub 2, all the way up to mn plus m prime sub n. Now, we want to show that the encoding of m double prime is equal to the encoding of m plus the encoding of m prime. Now the encoding of m is equal to p sub m of 1, p sub m of 2, all the way up to p sub m of n plus k. The encoding of m prime is equal to p sub m prime of 1, p sub m prime of 2, all the way up to p sub m prime of n plus k. And similarly, the encoding of m double prime is p sub m double prime of 1, p sub m double prime of 2, all the way up to p sub m double prime of n plus k. So now, this reduces down to the problem of showing that p sub m double prime of 1 is equal to p sub m of 1 plus p sub m prime of 1. P sub m double prime of 2 is equal to p sub m of 2 plus p sub m prime of 2, all the way up to p sub m double prime of n plus k is equal to p sub m of n plus k plus p sub m prime of n plus k. Now notice how it suffices to show that p sub m double prime of x is equal to p sub m of x plus p sub m prime of x. P sub m of x is the interpolating polynomial of the message m. Applying the Lagrange interpolating formula, we get that p sub m of x is equal to m1 delta 1 of x plus m2 delta 2 of x, all the way up to mn times delta n of x. Similarly, we have that p sub m prime of x is the interpolating polynomial for m prime, which is given by m prime sub 1 delta 1 of x plus m prime sub 2 times delta 2 of x all the way up to m prime sub n times delta n of x. And we have that p sub m double prime of x is the interpolating polynomial for the message m double prime. Now substituting values for m double prime sub 1, m double prime sub 2, all the way up to m double prime sub n, we get m plus m prime sub 1 times delta 1 of x plus m sub 2 plus m prime sub 2 delta 2 of x all the way up to mn plus m prime sub n times delta n of x. Now distributing the m's and the m primes and then grouping terms, we should get that p sub m double prime of x is p sub m of x plus p sub m prime of x. Thus, we have shown the above statement, and thus the encoding of m double prime is just the sum of the encoding of m and the encoding of m prime.